Good afternoon. This is Darren Riley with IAC Acoustics, and today we're going to be going over HVAC noise control products and systems. Again, my name is Darren Riley. I'm the HVAC product sales manager here at IAC Acoustics. So good afternoon. IAC Acoustics is part of what is called CAG. It's abbreviation for Catalyst Acoustics Group Company. And the Catalyst Acoustics Group, it's kind of a tongue twister there, is a parent company of an elite group of acoustic, seismic, vibration, and noise control companies that together we offer the broadest portfolio of noise control solutions in the market today. As you can see on the bottom left-hand there, we established, IAC did, back in 1949 with Martin Horshorn as our founder. We were in Bronx, New York, but we have now moved our headquarters office over here to Naperville, Illinois. Tom Hines is our national sales manager and director, been here for 19 plus years in this industry, and myself, Darren Riley, with the HVAC product sales manager, I've been 17 plus years in this industry as well. Today what we're going to do is go over HVAC noise control products and systems. Our presentation topics is what you will see there as bullet pointed out. And so we're going to kind of dive into these. We're going to fly through some of these areas and topics because, again, I've got 30 to 40 minutes and I've got a little bit, actually a lot to I want to present here a little bit today. What makes IAC Acoustics superior to our competition? We are strategically located with our manufacturing facilities in the major markets. We do this, and this helps us to minimize any type of, if it happens, a damaged shipment. We also are great in being able to reduce shipping time, and we actually have very low freight costs. Also, IAC Acoustics is the industry-leading quick ship program company. When you're dealing with HVAC products, sometimes you might need these things in a very quickly manner. We have a 5-day and a 10-day business days lead time option for all of IAC's full product line. Now, this does not include, obviously, something that's going to be custom made, possibly made out of aluminum or made out of stainless steel material. That still takes time as we do not stock that material. But anything made out of galvanized, we can do it in 5 days and or 10 days. No other manufacturer offers such a broad option and accelerated deliveries whatsoever. We also are 100% USA made. So again, 100% of IAC successes feed from local economies and U.S. businesses. We also offer a broad range of union affiliations. As you see there, New York Local Union 28 is kind of a hot one there in the New York market in Manhattan. The other thing is, too, is that we carry what is called an International Sheet Metal Workers Union label. That also coincides with the local unions across the United States there as well. Also, we can do non-union fabrication, too. Our products are reliable and consistent. Our products are fabricated using the same designs, drawings, materials, and tooling that were used in the Bronx for decades, with reliable and proven performance in the field for over 72 plus years running strong. IAC's brand has stood for reliability, and for HVAC noise control systems are a part of our heritage. We also focus on solutions developed from standard models and configurations. We have worked with many different acoustical consultants, engineers, contractors, and owners. That way they know exactly what they're going to be receiving from the moment they actually are looking at getting it from a quote to an order to the job site. We are 100% transparent with our cost-effective price and product description. We also serve both the construction market and the acoustical engineering community there as well, because we believe that owners deserve the support of independent consultants at the same time they're designing and budgeting their projects. IAC's broadest product portfolio in the market includes a full range of sound attenuators, multiple acoustic louvers, profiles, packless silencers, elbows, pipe and duct lag material, transfer vent silencers, and now our power flow heavy gauge silencers, which are fully welded as well, that are good for stack type situations. That is now back too. We have two excellent tools for HVAC. We have our IAC virtual silencer and louver tool, which we will go over here shortly. And we also have our snap tool, and I will show you that as well. We'll start out with the snap tool there. But what I want to kind of do now is kind of go through some of our different duct silencer and louver operating principles. As you can see there in that beautiful purple picture there, you can see a nice pictorial picture of the inside and outside of a rectangular type silencer. Inside, you'll see the baffles that is inside the actual outer casing of the actual silencer. So here we go. Ventilation and air movement systems utilize ductwork silencers to reroute or route air from one location to another. Noise can easily be transmitted along with the airflow. We'll go to that here shortly. Silencers and louvers operate by absorbing sound as it passes through the silencer or louver, the open air passages, while imposing only a minimum restriction on the airflow. Here is one of our simplest design for a duct silencer. I like to hit on this because there's a couple things here I like to actually stress. The first one is note number 6. It is the bell mouth entrance and exits. This minimizes turbulence, pressure drop, and self-noise. Those are the 3 things that you're going to be actually wanting to focus on for duct silencers and for louvers there as well. But again, minimizing turbulence. When you look at the bell mouth entrance and exits, the neat thing about our silencers that are different than everybody else on the market that is out there today, either end can be forward, reverse. Flip this silencer over, top to bottom, bottom to top. Same thing, left end to right end to left end. It does not matter. Reason being, it has the same percentage of open air passages versus the actual splitters inside. The nice thing about it too is the acoustical baffles are designed for maximum attenuation at low frequencies. Now, this is the toughest job of all to try to attenuate. Another nice thing of this, the shell noise radiation is minimized by the double scan or splitter construction. So again, when you look at our silencers, they are excellent in actually handling attenuation and at the same time minimizing turbulence, making sure pressure drop is very, very low, and also at the same time not eliminating, but making sure that there is minimum self-noise being put back into the system. Today, we're going to also look at these bullet point factors here as well, starting with face velocity and face area and moving on through here. So we'll take a look at these here as we look at our different products. Face area and face velocity. Face area, simple equation. Width times the height. So we have a silencer at 24 inches wide by 24 inches high. Times that together, you get 576 square inches. Convert that to square feet, you have 4 square feet. Face velocity. This is CFM divided then by the face area, which we just did. So, for example, here we have 4,000 CFM for this going into the silencer. You divide that by 4 square feet, you now have 1,000 feet per minute flowing through the silencer. Aerodynamic airflow resistance. Right here, you'll see in the red box is the Bernoulli equation. When you look at this equation, you also have to take a look at how this is actually measured for pressure drop. It is measured in inches of H2O at a given velocity, feet per minute. So this is measured from difference in pressure upstream and or versus downstream of a silencer and or it could be of a louver. The picture that you see below here is a pitot tube being inserted before the silencer as air enters into the actual ductwork before it reaches the silencer. As air flows through the silencer, it goes through the pitot tube, through the actual manometer, which measures the actual pressure drop system before and after the silencer in inches water gauge. So there's some really neat videos that we have online too that you can see. You can actually see how this is actually done. I would implore you to get online and take a look at it. It is actually pretty neat to see how this is actually measured. In our catalog, we have a really neat area design for each individual silencer. This is for our model LFS, where we actually show all the different aerodynamic performance for pressure drop. If you need to do some interpolation, you can do that. If you need help with doing interpolation in between, please feel free to give me a call or send me an email. I'll be glad to help you out. Now, this is kind of neat. Take a look at the silencer on the left, and then take a look at the silencers on the right. Please note here that half gaps and half baffle thicknesses are H and D, respectively, and performance is only based on these parameters. Now, again, take a look at the silencer on the left, take a look at the 3 on the right, all having a different configuration. All have the same acoustical performance of that of the one on the left, thus assuming HD and L are the same. So the number of baffles and air gaps, they only affect the flow area as does the height and or number of the span of the baffles. having more baffle arrangements within a silencer, you will then have more flow area. You will also then have lower air gap velocity, which relates into lower pressure drop. Here's a really neat pictorial of forward and a reverse flow. Up top, you have positive forward flow, just kind of a description because you can kind of see what it looks like. That is where the fan pushes air out through. And then at the bottom, you have negative and or reverse flow. Again, air being pulled directly into the fan. Acoustic performance for dynamic insertion loss, DIL. So when you first look at this loss, it depends on the flow, if it's forward and or reverse. Next, here it is shown as in the forward flow, showing air flowing in the same direction as the propitiation of sound. So for this type of loss, this would then be the difference between the sound power or intensity levels measured in or at the same point of the ductwork, again, before and after the insertion of the silencer. So there at the bottom, you see a specific type of calculation. Should you need to calculate this type of loss, send me an email, give me a call. I would be glad to take a moment to go over this with you to see how the calculation works. Also, in our catalog, we do show some excellent tables for dynamic insertion loss for all of our different silencers. Again, any interpolation that you need to have done, please contact us. We will be glad to help you out. Next is self-noise. This is important. So at the top left, you're going to see some self-noise that can be caused with interaction with the perforated material of a silencer. At the top right, some self-noise can actually be generated right at the entrance of the silencer. And then at the bottom, this is the illustration where you can see some of the self-noise can be generated at the silencer, at the discharge of the silencer, with the effects of separation of the air flow. Thus, this could cause some turbulence within the airflow run of duct down. So let me kind of go this with you as well. Again, you see the bell mouth entrance and exits on this. That, again, minimizes turbulence. You can see at the arrow on the right for the entrance impact comes in evenly, and at the bottom, it exits evenly there as well. A lot of silencers on the market today, at the discharge end, it tails off, the baffles do, and the middle baffle would come to a point. Air follows what, everybody? The path of least resistance. So as air comes out, if it is being angled off in the middle, it's going to be basically crisscross and going to have some rumbling down the run of duct. As air leaves the actual discharge end of a silencer tube, if it is actually angled, it's going to hit the side of the actual ductwork, could cause some bump rumbling, and then again it's going to rumble on down the run of duct. Silencers do two things. They help control the air movement, and at the same time, they should be quelling noise, not putting noise back into the system. Again, I will come back and say our silencers have one of the best and most effective designs to minimize any type of turbulence that will be emitted after it leaves the actual silencer. Here again also is at the bottom, you see is a nice little calculation showing how this self-generated noise is calculated. And again, a couple of pictures showing the source generated of the sound from the fan, whether it be forward and or reverse flow, how the sound kind of looks and populates and where it's at. You can see in the bold area of the red, the self-generated sound, and then the airflow, again, evenly. As it goes in forward flow, it evenly goes into the air passages and out, or in reverse. It pulls it in evenly and comes back to the fan evenly. Another table in our catalog, we do show the self-noise power levels. So again, take a look at our catalog. It is filled with a lot of resources and a lot of knowledge. Again, any type of interpolation needed, please contact us. We will be glad to help you out. Flowing through our presentation. Now, we're going to go a little bit into our product ranges. We're going to fly through this here a little bit. All of our products, all of IAC silencers and louvers were developed in response to the specific requirements from acoustical consultants, engineers, building owners, and contractors. Having been tested for performance, they provide some of the most economical choices for solving the wide variety of noise control problems encountered in HVAC engineering. Let's go through this. As you can see, the Quiet Duct Commercial Series. This is a very popular series, And as you can see, for these three, commercial series, ultra green, and a hospital grade, they all have LFS or UG or H in front of it. Those have the same baffle configuration and percentage of open air passages, and so they are, again, almost one and the same for design, but it's what is actually inside the actual baffles themselves. For the commercial series, that is fiberglass. For the ultra green, it is green. It is actually antifungal, anti-cotton filled material, packed very, very tightly. Sometimes actual a 3-foot and or 5-foot of this type of silencer can actually outperform that of fiberglass. And then when you move on down there to the clean flow, hospital grade as we call them, again, this is still filled with fiberglass, but it also then comes with polyethylene liner, the heat seal bag, and the standard honeycomb acoustic film material here as well. So let's take a look at this. This is a hospital grade film liner with the acoustical standoff. When you look at this, you have the solid noses on either end. You actually have the perforated material. Right behind the perforated material, you are going to get a wire mesh track. What this helps to do, it helps to make sure that that heat-sealed polyethylene bag does not adhere to just the flat surface of the perforated material. This also helps with acoustical performance as well. The standard honeycomb, the acoustical standoff, is right behind that, right in between the heat-sealed bag and the fiberglass. The nice thing about our polyethylene bag is this, is that when you take cellophane and wrap food with it, you are protecting the foods and make sure that it stays what? It stays prudent, or you can still eat it at a later date. It has no holes. So again, no air can penetrate it in order to actually make the food go bad. Now, the nice thing about our polyethylene bag, it is not like that. It is not a solid. If you actually see it and you kind of blow on it and it kind of expands out, it actually has tiny, tiny holes into it. So it still allows air to pass through it and come into the fiberglass, do what it needs to do as a normal silencer does, and come back outside the actual perforated material and continue on. So what does that do? That makes sure that our hospital grade type silencers give peak performance for insertion loss while at the same time minimizing pressure drop. Some other products we have that are getting really, really more popular are our elbow silencers, or just elbow silencers, not just ours, but everybody's. But the nice thing about their elbow silencers, you can see there, it still has the same baffle configuration as of a rectangular for the LFS, LFM, and so on. We can also now do these in the ultra green. We can do them in the hospital, and we can even now do them in packless. We can do these in galvanized, 304, and or 316 stainless steel. We also then have our, okay, real quick, down below the left corner, you can see the inside of a baffle, or inside of baffles of an elbow silencer that are being built in the shop. So it's kind of neat to see how that looks. Our baffles are also the turning vanes inside an elbow. We have our Ultra Pals packless silencers. Again, the packless silencers look like a normal rectangular silencer, but again, inside the actual baffles themselves, there are no infill material of any kind. We have our quiet duct conic flow silencers, and then we have our D-duct diffuser silencers. Now, these should be working in conjunction with an axial type, a vane axial type fan. These are axial type silencers. They are a diffuser and silencer built in one. The bullet that you see there in the middle, that actually is to be sized in conjunction and in correlation with the vane axial fan. That way air flows evenly from out of the fan through the actual D-duct diffuser silencer. And what this is actually a silencer that I've nicknamed, it's called a dump law silencer. Inside the conic, you actually have a square housing. What this silencer does is, ultimately, it is to give you an aerodynamic regain system that lowers the pressure drop of a vane axial type fan. So case in point, let's say the fan has 3.5 static pressure itself. Adding a axial type D-duct diffuser or silencer to it, you will drop it anywhere between 1/4 to 1/2 inch pressure drop. All depends on the flow. Some other products, we have our Quiet Duct Ultra Low series. These silencers are great. They actually handle the 31.5 octave band, which is the lowest band. And then we have our Quiet Duct Ultra ZAPD, zero added pressure drop silencers. You're going to see there Z6A, 9A, and 12A. The 6, 9, and 12 are as you see on the left-hand side of the silencer, picture of that. That is the W2 dimension. That is a set dimension. It is not modifiable at this time. The baffles, instead of being on the inside, like a standard rectangular silencer, they are on the outside. It is a winged type silencer. These have been designed from building owners and contractors who have needed something like this in the past. These are a little bit, I would say, more on the custom side. So if you need to have these type of zero added pressure drop silencers added to a system, again, the systems must be able to incorporate 6, 9, or 12 inches in width. You can stack these, by all means, go for it. You can have any height that you want. But again, the width number 2 is going to be 6, 9, and or 12 inches in width. Moving on. As you can see, this is directly right from our website here at IACacoustics.com. You can see our Louver catalog and different specifications and performance cut sheets. Let's go over this slide here. Our acoustic louvers are multi-purpose. They permit air to flow while shielding the environment from unwanted noise. Now, a lot of people are starting to design to percent of free open area. I am a little bit old school. I like percent of free open area, but I like to design to performance first. Percent of open area then is what it is. So when you look at some of our louvers from percent of open area standpoint, the Model R and LP louvers, they are variable across the width because the blades are airfoil shaped. At the intake and discharge of a louver area, you have 100% free open area. It is a hole, right? But at the closest point, at our louver blades, you get down to around 18 to 20% of free area. Now, because of the diffuser effect on the discharge sides of our louvers, actually, you get what is called, again, a pressure regain, and the louver performs way better than just 20% free open area. Based upon the testing and analysis of the 500L testing requirement that we have from AMCA, our Model R louver pressure drop performance is equivalent to that of a straight-bladed parallel louver with 46% of free open area. The Model LP louver pressure drop performance is equal to roughly 50% free open area. So here, let's take this. The pressure drop listed in our catalog is based on the face velocity across the entire face of the louver, not just the free area of velocity. So for example, if you had a 10-foot wide, 10-foot high rough opening with 50,000 CFM, face velocity then would be 500 feet per minute. The face velocity would then yield a pressure drop of 0.27 inches water gauge for the IAC Model R acoustic louver, roughly at 46% free open area. Not bad. So, some other manufacturers rate the performance based upon air velocity through the free area, whereas here at IAC, we rate ours based on the air velocity across the rough opening, in which case the free area is not required for the calculation of just a pressure drop. So again, I like to look at performance because, case in point, I've done this with just free open area. I've taken a 10-foot by 10-foot high, wide by high opening. We've actually had to enlarge the hole to 14 by 14 to accommodate the free open area that they wanted. So again, I raise caution. Make sure you're designing to performance first. Free open area is just what it is. It is going to be, it could be 46, it could be 50, it could be 60, it could be 30. Performance is the key here. We show that we can also do our louvers as acoustical standalones. We can do them as screens, and we can also do our louvers as a louvered door. Here is a louvered screen wall system at a hospital, at a children's hospital, which is great. This was actually to accommodate, instead of doing a solid enclosure up top, we were able to actually cut the cost in half for the children's hospital, and our louvers actually outperformed a solid enclosure. Here's a small little enclosure encompassing some different outside equipment there as well. To the left, we also show them how to specify our acoustic louvers for the noise shield and or slim shield louvers. Here's the catalog data of our Model R and or 2R, which is 24 inches in depth. The Model LP, more of the low pressure drop, while the R is regular. We have our 4-inch and 6-inch depth louvers, straight parallel. And we also now have our SL12 and SL24 straight parallel there as well at 12-inch and 24-inch too. Moving on to some installation pictures here. We have a dust collector series that we did for PG&D down in Atlanta, Georgia. As you can see, we created the turning vane, 100% free open air coming out of the actual dust collector, going through our model MS silencers. We created the platform down below, and we basically took 4 silencers, put them together that you can see there, and we reduced the overall sound from 103 decibels at 3 feet away from this unit down to 68. Dyer Avenue tunnel silencers. As you can see, these were banked. This was a very huge project for us with the folks there in Manhattan. We provided silencers that were banked side by side and then nested and stacked on top of each other. It was a great project to be on, to actually see how large these openings can be and can take. And these silencers actually, or the large bank is 144 by 144, was handling 250,000 CFM flowing through. The Citibank building, again, another picture showing silencers that are nested and stacked. These are actually 304 stainless steel. These were the exhaust silencers for the new Citibank building down there in Lower Manhattan. Or the waterfront substation there in Washington, D.C. These are handling our SL6 type louvers. And you can see these are multiple louvers put together side by side and then stacked on top of each other. Now, it was somebody else, another engineer, that created the 4x4 tubular framing that you see, but they were able to actually screw these and bolt these to this frame in order to create the framing member that you see in the larger door. Up top, you see the louver screens there in green. Again, these are our SL4 louvers. We were able to encompass these and create a solid louver. They were delivered as a whole unit. This was a special custom type that we can do, but it was a request from the actual waterfront substation to have in order to go between each pillar. Pipe and duct lag material. We're getting close to the end here because I want to be able to go over the tools. This is a really neat type of material. It is a quilted fiberglass decoupler, mass-loaded vinyl noise barrier, then in between, and then is covered with an outer reinforced foil jacket. This is reducing noise from any type of duct casing. It is wrapped around the outside of the duct, not the inside, and it blocks noise. I will say this, in fact, that the 1 inch that you see here can handle, has an SEC rating of 29. I like to use this in lieu of the HTL casing silencers. Reason being is that HTL casing silencers has an outer layer of sheet metal at 14 gauge, fully welded, an inner layer of 18 gauge, and in between the 2 layers of sheet metal are 2 layers of sheetrock. They get very heavy and they can get very expensive. By applying the duct lag material instead of that, you can do a standard silencer at 22 gauge casing, 26 gauge perf, wrap it in the 1 inch and or 2 inch, and get anywhere from 6 to 13 of total dBA reduction. A standard HTL casing silencer will give you 7 dBA reduction. So, case in point here, we have some silencers down in Texas. They wrapped it with this with a 2 inch. They got 15 extra dB reduction out of this because of that. So I will say this, if you have a question about this pipe and duct lag material, please email me. I will be glad to go over this with you and show you the different capabilities that this type of product has to offer. Last but not least, we have our quiet vent silencers. These are our transfer type silencers. These are great from room to room. As you can see here, we have the type C for ceiling insulation, type H for the insulation between the wall and or doors, and the type W for another insulation for a wall, or the CT, that is from one movable partition to the other. And then we have the vent shafts, the type S. These are some great transfer vent silencers. The government uses these quite a bit. I will say this, we've put them between room to room at a Marine Corps base, to where you can actually be watching a movie in one room, the drill instructor can be yelling at the recruits in another, and neither can hear each other from room to room. Also there in the quiet vent catalog, we are updating this catalog, so you'll see that coming shortly here onto our website. But this gives you, again, some overall performances there for noise reduction and decibels, and also a bunch of different models and sizes. Do not hold us to just these sizes or models. We can actually do any size that you need. This comes to the end of the actual presentation, not the webinar, it's just a presentation, as I want to take a moment here and go over the snap tool and the virtual tool. So when you are looking at utilizing the snap tool, the really neat thing about this is that this tool allows you to do what I call a system analysis or a system mock-up. This is actually pretty cool. What I've already kind of preset it here, and what we're going to do is kind of a system where you actually have, as you can see here, you actually have a room characteristics. If you click on the room, you can change this. It defaults here. I've put in 30 by 30 width by width or length by 10 feet and 6 feet to distance listener. We actually have the ductwork going to the grill. If you need to see how that looks, it could be flush with wall or ceiling, junction with wall or ceiling, or junction of two walls of ceiling. I always say leave it with flush wall or ceiling because again, sometimes you just don't know. But that grill width is going to be 40 by 36. That will always be the same width as the duct hitting the actual grill. We are going to try to get down to a noise criteria of 45. So you can change this from noise reduction, noise criteria, or dBA. Most of the time you're going to be using the NC values. Once we have the room set, we go in and we plug in our, over here at the very end, you plug in your equipment. It could be a fan, chiller, cooling tower, whatever the piece of equipment is. Now, you can do this as manual entry. That is if you actually have the cut sheets. And though all of these octabands here, if you have all of those octabands on the cut sheet, enter those numbers in, it now is equipment specific. If you do not know and have the cut sheets, again, utilize what we have here. It is very conservative. You can plug in the fan CFM. You can plug in the pressure drop. Once you do that, hit OK. It's going to give you your values. So our starting dBA is now at 81. This run here, what we're going to be doing is we're literally going to be coming out of the unit of straight duct. We're going to be dropping. We're then going to be turning one direction and having to turn another to go to the room. So here what we have is we were able to then plug in a run of duct, and you can do this here. You have all the different type of areas that you can do. Typically what you're going to be speccing out is a 25 millimeter lining because most of the time it's line type duct, and you're asking for the smallest cross section. So remember, we were using 40 by 36. So plug in the 36, and if we have 50 feet of run of duct between this piece of equipment to the room, I plug in 27. I've been able to I've already preset this just a little bit here for the actual presentation. Now, let's skip this. This is where the silencer is, and we have a bend. So you can kind of see how this looks. You put a bend in, it's one bend, first off, 90 degrees, 36 inches, click OK. The same thing, now we're turning it to the actual room, and we're going to finish it off with a little bit of duct work before it actually hits the grill, right? So what we have here is this, if there's nothing in each of these segments, okay, this room is actually right here where the last segment that has something in it, that is where it's calculating. So we come back here, and before this bend, we put our silencer in. What we're able to see here is that a LFS model, and we can kind of do this. I always like to leave it on quick pick, and you plug in your width by height at 5,000 CFM. Remember, the equipment was at 5,000 CFM, and click OK. The nice thing about quick pick is it gives you 1, or it could give you 10. Here it gives us 8. And if you look at this, how this models and gives you the data back is in length. So it goes from 3 feet to 10 feet. Now, as you can see here, the pressure drop varies from different models. I always like to say if you're at 0.35, more conservative 0.25, then you're good. So you can select anything from 2.25 or less. Right here, I have a 3 foot that is going to work at the pressure drop 0.14. That's great. Why would I want to go to a 10 foot L? It still is going to work, but again, cost factor 2. So I always like to say I want to help out to the best of the ability with these programs. I've actually even helped out people find out that they don't even need a silencer using this tool there as well, and I let them know that. So again, we're in the business here to actually sell our product at the same time. We're selling our services too. So I'm going to select the 3 foot LFS. And as you can see here, this is a pass-fail program. If it's red, it fails. If it's green, it passes. look at this. Everything is green, so it passes. We started out at 81. We need to get to 45. I actually achieved an NC of 40. So this is a great tool to utilize. Again, doing a complete system analysis or system effect. So you can actually see what's going to be happening through the actual entire run of duct from equipment to the room. Now, correlate this to the actual virtual tool. You can go up here where it says PDF, click on this. You can then print this off so you can actually send this to an engineer, or the engineer can have this himself or herself. So this is, again, some great knowledge to have at your fingertips. Once you're done, save this. Then you can go over to the actual virtual tool here, and you can go in here and plug this in here and to create your submittals. Again, I've already kind of preset this for the presentation, but we'll go into here. You can click on silencers and louvers. For this presentation, we're doing silencers. Click on the blue icon that's pulsating. We know it's an LFS. You can either click on it. You can see all the different products down through here from that orange bar. You can even type it in, LFS, and it pulls up all the different LFS models. Click on the LFS. We can label this one SA-1. We know it is 40 by 36 by 36 at 5,000 CFM. And there you go. Your dynamic insertion loss numbers are there. Your feet per minute is a forward flow. Here's your pressure drop. Hover over top of it, click it in. That way it stays orange. Click the blue button to add it to your portfolio. View all your items, so that way you can kind of make sure that it is in your portfolio. And from there, then you can print your submittal pages. So again, here's another tool that is great for the market, and you're able to see your performance, and at the same time print off submittals that are needed for specific jobs. That way you can show these to the engineer and or consultant. So here's your performance model for the LFS. Again, the flow, velocity, pressure drop, insertion loss numbers, all your different type of constructions for your casing, your perforated liner, your media fill. If you had any media protection or end connections, you can do flanges. And then down here you have your width by height by length. So I know I've kind of gone through a lot of information within 30 to 35 minutes. Appreciate your time. If you have any questions whatsoever, I will leave this up here for the next few minutes. That way you can kind of, again, take down my name, my phone number, and my email. Should you have any questions whatsoever, please feel free to reach out to me. I would be glad to sit down and go over any type of equations, do a one-on-one with you, or or myself with another group, diving deeper into the actual snap tool and or virtual tools, and again, and or into any other products that we do have here for HVAC. Again, thank you for your time. Stay blessed and stay safe. Take care.